Morning all. Today I am going to explain electrical measurement and instrumentation subject. In this subject, I am going to explain one of the topic is instrumentation transformer. So myself are Mr. Muneeshwar, Assistant Professor, Electrical and Electronics Engineering, BV Raju Institute of Technology, Narsapur. So today I am going to explain instrumentation transformers. What is the instrumentation transformer? Instrumentation transformer is that used to measure the electrical quantities like current, voltage, power, power factor, and frequencies is known as a instrumentation transformers. So these transformers mainly used with the relay to protect the power systems. So in this subject and major role of these transformers to protect the power system subject. So here is main important role in this subject is we are studying this subject means we have to instrumentation different measuring instrumentations are there. So based on that measuring instruments to measure the voltage, current, power in the substations. 11 kV substation, 33 kV substations, or 220 kV substation. Nowadays 420 substations also is coming to the market, and 675 kV lines also is going to constructing. So in this subject we have to measure the different areas, different substations. So this transformer is mainly used with the relay to protect the power systems. And one more important point is it is also a transformer that is used to conjugate with any measuring instruments like ammeter, voltmeter, wattmeter, and watt-hour meters, etc. We have to measure the power supplies. So it protect the equipments of the relays. Major important is it protect the equipment of the relays. That's why we are using the transformers, instrumentation transformers, and it utilize the current transformations and voltage transformations properties to measure the high AC current and AC voltages, high AC voltages and AC currents. So these are the different instrument transformers here, different instrumentation transformers. These transformers used in substations and home appliances and industries areas also. And instrumentation transformers, two types of instrumentation transformers. Majorly, we have to use to measure the current is a current transformers. We have to measure the voltage is a voltage transformers. So one is current transformer, another one is voltage transformers, are also called as a potential transformers. So applications of a instrumentation transformers to measure the high AC current. In case of in current transformers, we have to measure the high AC current. In case of in voltage, we have to measure the high AC voltages. So in AC current, it is usually to measure used to low range of ammeter with suitable scent coils. AC current measure if we have to measure the AC current, then we have to use the scent coils. In case of in measurement of high AC voltages, low range of AC voltage meters we have to use and read the high voltages. So in this case, the high resistance connected in series. So voltage, we have to measure the voltage, we have to connect the high resistance, we have to connect to the series. In case of in AC current, we have to go for the scent coils, we have to measure. So for measurement of very high AC current and AC voltages, we can't measure this CT and PET. Then go for the HV instruments in the HV instrument transformers. So to insulate the high voltage circuits from the measurement of a circuit in order to protect the measurement of substation equipments. If we are not go for that high voltage instruments, then the AC, CT and PT will be burned out. So based on that, we have to go for the high voltage instrument transformers. We are going. So the basic structure of the transformers. So the circle of the diagram is called as a core, and the winding is called as a copper windings. So core is called as an iron core, and winding is called as a material we are used in uh, copper wires. So whenever you are giving the supply to the primary side, we are giving the supply to the primary side, the current is passing through the copper winding. So that is called as a primary side. Whenever you are giving the supply to the primary windings, then the flux will be generated. That flux is interacting with the core coils. The flux is interacting with the core coils. Then the iron body is act as a magnetism. Then the flux is transferred from primary coil to the secondary coil. The flux is transferred to the primary coil to the secondary coil. Then the power output will be generated. That is called as a V2. So in this case, we have to go for the V1 here. The current is passing through the I1, and number of output current is passing through this circuit, then the primary circuit, then the flux will be generated. In this case, the voltage also generated here. That is called as a E1, and the number of terms we don't know. So number of terms is called as a N1. So flux will be generated. That flux is called as a maximum flux. So whenever you are giving the supply to the primary side, the flux will be generated. The output of the voltage also generated. That is called as a E1. So this flux is transferred to the neighboring coil. Neighboring coil means is called as a secondary coil. This is primary coil. So secondary coil, the flux will be transferred, then the power output will be generated. That is called as a V2. The output of the voltage is output of the current is I2. Okay, so we have to go for the number of terms of the secondary time. We don't know, N2. Number of output of the voltage of the secondary terms is called as an U2. So we will get the value of these. So output of the voltage E2 equal to number of terms of the primary side N1 into d phi 1 by dt. Why I am quoting means dt means with respect of the time. How much time we are turn on the transformer? How much time you are off? So turning on, for example, 10 minutes. So the time interval also is very, very important. So one more point is the flux is transferred to the neighboring coil means that is called as in secondary terms. That is number of terms N2 into d phi 1 and 2 by 2. Why means 1 to 2 means the current is passing through the only primary side only. Then the flux is transferred here. The flux is transferred to the neighboring coil. We are not connected to the primary. We are not connected to the supply to the secondary side. Only primary we are connected. Then the output, the flux will be transferring the secondary coils. So the power supply of the d phi value is d phi 1 by dt plus number of terms in secondary terms N2 into d phi 1. So the supply of the flux primary side 1 and secondary side of the flux is 2. So d phi 1 2 by dt. So this is the equation, major equation. So mainly the transformer definition is, the transformer is defined as, transformer is a static device which converts one form of electrical circuit to another form of electrical circuit through the media of magnetic path. Through the media of magnetic path without changing frequency. The frequency is always, Indian frequency is always 50 Hz. So the transformer definition is, the primary output is transferred to secondary side. So the primary output of the flux is transferred to the neighboring secondary coils. So transformer is a static device which converts one form of electrical circuit to another form of electrical circuit through the media of magnetic path. Then the output will be generated. According to the thumb rule, transformer is act as a AC operating device. Transformer is act as a AC operating device. So this is the simple diagram and simple explanation. Then go for the instrumentation transformers. So instrumentation transformers is here line voltage, line to line voltages. The potential transformer, also called as a voltage transformers. we are connected to the line to line. In between the line to line, we are connected here. And current transformer, we are connected. This is called as a CT. Current transformer, we are connected to the secondary line. So come to the point is here, voltage transformers and primary winding is more, secondary winding is less. Connected to the voltmeter here, voltmeter we are connected, and protection relay also we are connected here. So how much current is passing, how much voltage is passing through this line to line, we have to record the value of voltmeter. Starting I am explaining. So measure the instrumentations is called as a voltage, current and power. Measure roles. So in this case, line to line, how much voltage is passing through the line to line voltage, we have to measure the voltage value is called as a voltmeter. That is called as a protection relay also we are connected here. And one more point is watt hour meter also. Why? Because how much line is connected, how much time is connected, watt hour meter we have to connected here. Means 1 hour, for example, 1 hour, 10 to 11. That is called as that time also recorded here. Everything is recorded. That's why we are connected to the watt hour meter we are connected. And come to the point is load current is here passing through the load current. So the current transformer we are connected to the secondary line. Secondary line connected to the secondary line, and ammeter is series with the ammeter, we are connected to the ammeter and also connected to the protection relay. So in this line, how much current is passing through the circuit, we don't know. So by using the ammeter and voltmeter to record the value of line voltage, line current, we have to measure. So this is the major diagram of this circuit. So one by one I will explain individually the current transformers. The function of the current transformer, the principal function of the CT also called as a current transformer, is to produce a proportional current at a level of magnitude, which is suitable for the operation of low range measuring or protective devices. So primary side is more terms compared to the secondary side. So higher current to the lower current, we have to measure, for example, 100 by 5 amps. So 100 amps is flowing through the secondary line and 5 amps is flowing through the 100 amps is flowing through the primary line and 5 amps is flowing through the secondary line. That is conversion ratio we have to measure, and also we have to protect the relays. And also we have to measure the protection of our major system, power system. So the primary and secondary currents are expressed as a ratio of 100 by 5 or 1000 by 5 amps. So which means the 100 by 5 ratio is called as a CT. 100 amps is flowing through the primary windings, will result the 5 amps. After the results of the 5 amps, the flowing through the secondary winding, provided that the current is rated bond is connected to the secondary windings. So 5 amps is flowing through the secondary winding only. So the simple construction types of a CT transformers, one is Wund type, another one is bar type. So Wund type means the copper wire are constructed into circular shape, and Wund type means the plate. Bar type means the plate, copper plate is connected to the bar type. Next one, the connections of the current transformers. The line to line voltages here, so the primary side is connected to the line here, line connected to the secondary line connected to the secondary. So primary part is here and secondary part is here. So this is called as a single ratio CT transformers. Then go for the secondary diagrams. The primary current, one line is connected, the 200 to 400 amps is flowing through the one way, and secondary lines is primary side we are connected to the one part, primary part, and secondary part we are connected to the multiplications. So multi ratio means is called as x1, x2, x3. So we have to divide the value. So 200 by 5 amps, 200 by 5 amps or 400 by 5 amps. So primary terms 200 by 5 amps here we are connected, and 400 by 5 amps. total current is 400 by 5 amps, but the multi ratio means we have to divide it into two parts here, 200 by 5 amps. One more point is here called as a constructions of the Doug Hunt type of relay. So this type of relays we are used in our BVRIT campus Indonar solar project we are used here. So why? Because the circular shape here, circular shape CT transformers and PT transformers, we are connected to the wire and connected to the practical data we are calculating here. So in this line, in this bar line is called as the wire, primary conductor. So how much power is flowing through the primary conductor, we can't say. So by using the CT we have to measure the value of secondary terms here and iron core. So secondary windings we are connected, so connected to this plus and minus, we are connected to the supply. So how much power supply is flowing through this primary conductor, so we are connected, but the meter CT gives the current flowing through that wire is directly connected to the meter. So the how much current is passing through the conductor, directly we will measure the value. Then go for the potential transformers. What is the potential transformer? It is also called as a voltage transformers. So sometimes it is also called as a voltage transformer. It is called as a step down transformers, having a many primary terms, but a few secondary terms only. So here is that primary terms is more compared to the secondary terms, means it is also called as a step down transformers. So in the step down transformer, that voltage decrease and the current is increase. So step down means the voltage is increase and current is decrease. Compared to the step up transformers, voltage is increase and current is decrease. So thus the voltage can be easily measured by using the low range of voltmeter instruments. So these voltage values we have to measure, means low voltage voltmeters we are connected to the circuit, then we will get the values. The voltage is step down is known as a ratio of the voltage ratios. Next one, the constructions. The potential transformers has a many primary windings and terms, but a few number of secondary winding terms. That is also called as a step down transformers. In case of step up transformers, primary windings is less compared to the secondary windings, then that called as a step up transformers. The voltmeter is connected to the secondary winding, is usually it is called as a voltmeter. Secondary means the 230 volts is converted into 150 volts. So the primary terminals are connected in a parallel across the line to which the voltage is to be measured. The voltmeter reading gives the transformations value of the voltage across the secondary terminals only. The deflection of the voltmeter, when the current is voltage is passing through the meter, the deflection will be started. So the voltmeter when is divided by the transformation ratio is given by the actual voltage across the primary windings. Then the line voltage is equal to the deflection of the meter by transformation ratio. The transformation ratio is equal to output of the voltage by input of the voltage, V2 by V1. So these are the major important roles we are using CT and PT in the power system at substations. So we have to protect the value, protect the equipments in the substations and in the colleges and industries. Everywhere we have to protect the values. Why? Because CT will give the direct current, PT will give the direct voltage. If the voltage is increasing, then the times of the transformer maybe will stop the value or maybe increase the value. So in the BVRIT we are using around 400 units 4,000 units we are utilizing in the campus per day. So means 350 kVA transformers we are utilizing here. So we have to use this CTPT to protect and also use the relays to protect the transformers. So the major important roles of this transformer, CTPT and relays to protect the electrical power systems. So this is my presentation. And one more point is potential transformers common ratios. So RYB three lines are there here. So the PT we are connected. Primary terms is one and secondary terms. And bottom of the part is called we are connected to the relay. So this ratio is called as 14,400 by 120. What do you mean by the 120? Means the 120 is phase RYB. Three phases difference is called as 120. So 120, 14,400 by 120, that equal to 120 by 1. Value terms ratio we have to connect to the CT preparation, CT design. So 4,200 terms by 120 terms means that is also called as 35 by 1 term. 1 term means we have to winding the new CT preparation point of view, we have to go for these calculations. 2,400 by 120 means that is 20 by 1 terms. We have to connect it to the CT preparations. These are my major important topics. So this is my presentation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.